HD Explorer is software made by Soterix Medical that can be run on any Windows 10 or 11 PC. This is a demonstration of HD Explorer version 8. This release has many new features, including the addition of ultra-high-definition layouts on select heads, expansion of temporal interference or interferential stimulation modeling to all heads, increased TDCS Explorer capabilities, enhanced visualization capability, and ability to always load saved montages at any time. There are 3 steps to use this program. Let's begin with Step 1. Note that the interface has 3 sections: the control panel on the left, the help section on the right, and the displayed results in the middle. The help section and control panel can be minimized, and the entire application resized as needed. Select the subject that you would like to explore for current flow from the control panel. The base HD Explorer version comes preloaded with 3 adult male heads, 1 adult female head, and 2 standard heads. The adult male 1 and the MNI 152 head now include the new ultra-high definition layouts, while the other head models incorporate the standard 1010 layout. Note that the 336 electrode model can be used to simulate sponges as well as extra cephalic and neck locations. Let's select adult male 3 and the 93 electrode density option. Once the head is selected, the different segmentation masks can be viewed via the anatomy viewer in the middle. The skin, bone, CSF, gray matter, and white matter of the head can be seen in 3D. You can zoom, pan, rotate using the keyboard and mouse. See the help section on the right for specific instructions. Selecting lock orientation will lock the viewing angle so that you can visualize different masks at the same orientation. Selecting the center view will reset the view to the original starting view. Step 2. In the second step, you design your own electrode montage. There are 2 major categories or stimulation modalities available: Basic, which provides TES, and HD-tES modeling, and the IFS tab for modeling temporal interference. We will explore the Basic tab first. You will notice 2 different layouts are available, by which electrodes, their current, and polarity can be selected via the drop-down menu in the Layout tab. The flexible layout allows you to select the desired electrode and assign its current and polarity. The uniform option assigns the same current to a group of electrodes for the selected polarity, anode or cathode. For example, let's create a typical 4x1 HD montage. This can be done using both flexible and uniform layouts. Let's begin with the flexible layout. We'll be using a total of 5 electrodes with 1 center electrode surrounded by 4 returns. First, select the location of the center electrode on the 2D electrode layout. In this case, we'll select CZ. Now enter the current for the center electrode at its location. I'm going to enter 2 milliamps. To the right of the 2D electrode layout, the corresponding 3D electrode layout can be seen. The electrode that is selected will turn from green to orange in the 3D view. Here, orange indicates that positive or a nodal current has been assigned to the electrode. Now let's select the first of the 4 electrodes forming a ring. I will start with FC1, and I will enter -0.5 milliamps as the current. Notice that with each electrode selection, the 3D electrode view changes, showing the selected electrode in blue and the underlying cortical anatomy. The 2D and 3D electrode layouts can be resized by simply dragging the white line divider left or right. Let's select FC2 and CP1 electrodes and enter -0.5 milliamps for each of them. Now select the 4th and final outer electrode. Let's choose CP2. You'll also notice that HD Explorer automatically enters the amount of current with correct polarity in the final return electrode. This is because the total current in must equal the total current out due to current conservation. Now let's try the uniform layout. First, select the total amount of current we will use. In this case, we'll also use 2 milliamps. We will also use one center anode and 4 surrounding cathodes as we did in the previous example. If you already have electrodes selected, click on the X next to the electrode in the electrode's current box to deselect the electrode. With the default arbitrary selection method, click on the anode radio button, then select where you want the anode on the scalp. We will use CZ as the anode. Now, select the cathode radio button in the selection method box and click on the 4 cathodes you want to use. In this case, we'll use FC1, FC2, CP1, and CP2. Notice that under the uniform setting, HD Explore automatically splits the total current based on the number of cathodes selected. If you want to save your montage for later analysis, you can simply go to File, then Save. When you open the program again, simply go to File, Load, and load the saved montage file. If at any point you want to make the main window bigger, the control panel can be minimized using the button on the top right of the control panel section. To return the control panel to its original size, just click the button again. Now, let's explore the IFS tab. As soon as you select the tab, you will notice 2 2D electrode layouts. The one on the left corresponds to the first current source, while the one on the right corresponds to the second current source. Make sure you have the flexible layout option selected in the Basic tab to follow the steps in this video. As an example, let's select F5 as the first electrode for the first source and enter 2 milliamps. Then select FC3 as the second electrode. Note that the resultant current of -2 milliamps will automatically populate. Please note that while temporal interference uses sine waves, the current polarity concept is simply used here to ensure current conservation. Next, let's select F2 as the first electrode for the second source and enter 2 milliamps. Then select C4 as the second electrode. As with the HD-tES modeling, the 3D electrode layout shows the selected electrode. If at any point you need assistance on what to do, click the Help section on the top right of the screen and the section will expand providing instructions. Step 3. Explore current flow in the head. HD Explorer will now allow visualizing current flow through the entire head in both 2D and 3D. The default view is 2D. Here, you can select to view the electric field and the subject MRI individually or together. You can navigate through the head by simply clicking around in the 3D space, or moving slice by slice at 1 mm resolution by using the sliders in the control panel. When performing temporal interference modeling, the 2D and 3D views will show the modulation depth, whereas when performing TES modeling, the 2D and 3D views will show the electric field. Irrespective of the modeling approach, selecting a region of interest via the labeled drop-down menu will automatically orient to that location and demarcate the region by drawing a border. The visualization can be adjusted by toggling the radio buttons to isolate, highlight, or spotlight the region as well. The selected field intensity or modulation depth value in the control panel shows the field intensity or modulation depth at the intersection of the crosshairs. This can be used to determine the field at any voxel in the head. Next, the corresponding MNI location of the voxel is displayed right next to the slice coordinates. The field or modulation depth intensity scale can be adjusted as needed by using the buttons or by manually entering the values at the top and bottom of the bar to better depict current flow patterns. To explore the current flow in 3D, just click the 3D option in the control panel. The model can be rendered either as a solid or transparent surface. The solid surface is the default view. You can zoom, change view, move, and rotate the 3D view as before, using your mouse and keyboard. Note that the selected electrodes are also visible in the 3D layout. By clicking Display Cutting Plane, a plane will be shown in the rendering along with the pitch and yaw angles, as well as the distance from the center of the plane. These controls can be adjusted using the scales to define a precise location to cut the 3D volume at the plane. To explore current flow inside the head, simply click Cut and the head will be cut at the location. If you want to undo the cut, just click Undo Cut. The intensity scale can also be adjusted here in the same way as the 2D view. By selecting Instant Cut, the plane will cut the head volume in real time as you adjust the cutting plane. Now let's talk about exporting data for further post-processing. Clicking on the line export option will present you the option for setting the start and end coordinates either manually or by directly clicking on the 3D surface plot. For the direct clicking option, first click the green crosshair next to the start point. Notice when you do that, the cursor changes to a plus crosshair. Now click anywhere on the 3D surface to register the start point. Likewise, do the same for the end point by clicking on the red crosshair. In the manual option, you enter the coordinate values via slice or MNI coordinates. Clicking on Cut by Line will cut the 3D volume at the line location. The cut can be undone. The intensity values induced along this line can now be exported to a CSV file by clicking on the Export button. The file will include the X, Y, and Z coordinates of the interpolated locations along the chosen line and the corresponding induced electric field or modulation depth values. Likewise, clicking on the Sphere Export option will present the option for setting the center of a sphere either manually or by directly clicking on the 3D surface plot. For the direct clicking option, click on the green crosshair next to the center. Then click anywhere on the 3D surface to register the center coordinate. In the manual option, you enter the coordinate values of your choice, followed by the radius of the sphere. Clicking on Cut by Sphere will show you the 3D volume contained within the sphere. This cut can also be undone. The intensity induced within the sphere can now be exported to a CSV file by clicking the Export button. Similar to the line export option, the file will include the X, Y, and Z coordinates of the interpolated locations within the chosen sphere and the corresponding induced intensity values. Let's go through one more example. Going back to step 1, let's select Adult Male 1, but the 336 electrode density option this time. For step 2, let's select Uniform. Then select the total current you want to use across all electrodes. In this case, let's choose 1.5 milliamps and choose Pad Configuration in the selection method. Click on the drop-down menu under Anode and select F3. Note how HD Explore simulates a sponge pad about the F3 location by selecting 9 electrodes. Using this approximation approach, the current is split evenly amongst the electrodes simulating a sponge pad at F3. Then, using the drop-down menu under Cathode, select the right shoulder, or RSH, location. As before, click on the Explore Current Flow button to explore current flow in 2D and 3D. In this way, you can use HD Explore to create any HD-tDCS, conventional tDCS, and IFS-TI montage. HD Explore, another innovation only from Soterix Medical. HD Explore is optimized to work with Soterix Medical family of HD and single-channel simulators. For more information, visit soterixmedical.com.